As a matter of fact, if you looked inside of my, what do they call it? Well, if you look at my page, you'd have seen a post with a photograph of what has been happening on my screen since 5:45. So often, I guess they update this every other day, and that is why you really have faith. Have faith with you. Good evening again, everyone. We just have a few getting in. You know, maybe some of you were deterred by the long wait. And for the students who are on YouTube, this is not the concern of YouTube. It wasn't concerning YouTube why I didn't get on. As a matter of fact, those students who were over on YouTube, you would have seen me before 6 p.m. But TikTok is at it again. You know, it's quite an uphill climb with TikTok. And well, this little experience, I learned a little thing from it. So I know how my cameras will switch. The camera that goes over to YouTube is the same camera that goes over to Google Meet. So when TikTok closes, if I'm going to go over to Google Meet, then YouTube students will have to join me on Google Meet also. Right. All right, so let me give a few seconds before I get to the board. Good evening. All right, since I see 11 students joining, then it went down to 7. Then right now it's neither 7 nor 11. All right, since we have a little oscillation between 7 and 11 that goes over to 12 now, then I'm going to begin. So, good evening, everyone. Welcome again. And of course, thank you very much for joining. Thank you for causing your associates to be aware. You know, some individuals still would have told their teachers about it. And not only their classmates, but teachers also. So every now and again, somebody is on the live chat. Some of my old students, you're probably addicted to Richard James Mathematics Resources. One student left after COVID, and I saw him still in the live. The next one, well, he just left, and he's still joining the live, wishing to be a part of the class. And the student is saying, which page? That is a very nice question. I'm not going to tell you the page, but you should know that it's your algebra booklet. You find the page. Since you have the booklet, since you have the instructional manual, you find the page. Yes. Right, someone was saying that I should go over, or I should do algebra with fractions. That one is very hilarious. You know why it's so hilarious to me? Because if I stop and do everything that everybody else tells me to do, then I will not do what CXC tells me to do. I'm not telling you which page. I will never tell you which page. We are doing work from your instructional manual. And I have to tell you which page? Well, you have to use your brain this evening. You should be telling me what page because I don't have the same, I'm not using the same instructional manual as you are. You tell me which page so that I can tell the other students. I can't even find my instructional manual. Because this place is converted to a book factory. Yes, because it's a book factory at the moment, I cannot find my instructional manual. I should have at least 2 of them. So I shouldn't have any difficulty. Now, this evening, we're taking a look at algebraic expressions. And for the love of my life, I cannot find my instructional manual. Where can it be? Now, you all have the new manual. So I need you to tell me the page in the new manual so I can tell the other students. We're working with algebraic expression. As you can see on the board, we are looking at the building blocks of algebraic expressions. And they are algebraic terms. And I still haven't been able to locate any of my 2 instructional manuals. That's a mystery. Alright, I must find them over here. I start to see some old things among the new. So I know that my instructional manual is over here. Alright, so I am using the old manual, so I don't know. It's on page 11. Yes. I don't know because I'm not going to look. So you look and see where we have algebraic expressions and you tell me what page it is. You can't do that? Come on, you have to do better than that. We are following the instructional manual in a logical sequence. We are not hopping, we are not skipping, we are not jumping. The first thing that we did was directed numbers. Then we moved on to indices. The only thing that is left for you to do is your homework for indices. After indices, there's a topic. We are not skipping any page. So we are going in a logical sequential order, not skipping any page. We are moving to the very next thing. The very next thing that you should see is something similar to what I have on the board, which is algebraic expression. So you are saying that it's page 11? Can anybody confirm? Okay, great. Thank you very much. Students, you cannot have an instructional manual and the teacher is following the instructional manual to a T. Not skipping out anything, not jumping over anything, not going from side to side. But as soon as I finish one page, I move to the next page. Then I move to the next page. Then I move to the next page. And you are finding it difficult to tell me what page it is and asking me what page it is. Come on, man. You cannot be baffled by those simple things. The next thing you're going to say is that I don't give you any homework. I don't have to give you homework. Because when you finish the chapter, the homework is at the end of it. You do the homework. After you finish the homework, you check at the back of the book. If you want to look at the back of the book and then do the homework after, and then you don't learn anything, then it's going to be up to you. You have to take some responsibility right now. You can't give me extra work with the instructional manual when I have to sit down day and night, sometimes 16-hour shift to make that manual. All you have to do now is use the manual. And you're causing that to seem difficult. So what would you say if you had to write it yourself? Come on, do better than that, man. Alright, so we're going to be taking a look at algebraic expressions. And we have it there. The building blocks of algebraic expressions are algebraic terms. An algebraic term is comprised of letters and symbols. Now, sometimes when I talk about an algebraic term, they include everything in one, with the coefficient and everything. So you have to know, because of context, which one they are talking about. Okay? So here we have your algebraic term. This is your algebraic term. There you have the letters and symbols and students. In an algebraic expression, symbols may be representing any of three things. So don't follow the Americans and everything that they see, they call it variable. I've never seen something stupid like that in my entire life. If you write an algebraic expression and you give it to them, they say the variables are A, B, and C. Don't follow the Americans. There are many things that they are backward on in mathematics. And some of them they are doing quite fine. I did an applied algebra course, not applied algebra, applied calculus course with which universities again? With Harvard University. I learned quite a bit, right, and I got 97%. I think that I could have gotten 99. I don't think that I would have received the 100 because there was a topic there that I didn't want to do. See, I forgot. I am not remembering his name. When I remember, I'll let you know. Phase plane analysis, yes. Phase plane analysis, I just refuse to do it. So I don't think that I would have received 100 at all because I would have lost marks for phase plane analysis. All right. Yes, but when you see an algebraic expression, students, don't call them variables. All right, look at this algebraic thing. Look at this algebraic expression. F is equal to G mm over R squared. See that? We have 1, 2, 3, 4, 5, 6. Or let us call it just 5. So 1, 2, 3, 4, 5 symbols inside here. Well, in this particular case, the symbols are letters. We have 5 symbols there, students. Yet still, only 2 of them are variables. Only 2 of them are variables. So don't go calling every letter and every symbol that you see in an algebraic expression variable. Do not do that because you are going to sound like the Americans and that does not go down well with me. So if you see a letter, call it letter. Say it's a letter or say it's a symbol. But don't tell me it's a variable. Because if you are going to call it a variable, then you must know why you call it a variable. A variable, to vary, means what? To change. And to be a variable means that you have the ability to change value. But by looking at this, you don't know if they have any ability to change any value at all, so you cannot call them variables. So let's continue. So this is the algebraic term that we have right here, and the number that is at the front is called the coefficient. So we have the algebraic term and we have the coefficient. This describes what term we are talking about. So this gives the description, and this tells us how many of them. So that coefficient that we have there tells us how many a cubed b c to the power of 7 we have. So the term is a cubed b c to the power of 7. That's the term. How many of them? 35. And that number telling us the number of them is called the coefficient. Then we have another term here. P squared q to the power of 5. That's another one. So this is another term. But what do we know? There is no accompanying coefficient. And when there is no coefficient or accompanying coefficient, we say that the value of the coefficient is equal to 1. So 1 is the default coefficient. 1 is the default coefficient. Here again, we have another algebraic expression. We have a term in the denominator and we have a term in the numerator. The only two variables there, I'm going to take them for you. These are the only two variables. Right. And of course, a symbol in an algebraic expression can be either of three. If the symbol can be a constant. It can be a constant or your favorite. It can be a variable. And or three, it can be a parameter. Now, we know about the coefficient, we know about the default coefficient, and we know about the algebraic term. Now, there's no need for algebra if we are not going to manipulate the terms. Surely, we are going to manipulate the terms. We will manipulate the terms, and we are going to manipulate the terms. Now, the first means of manipulating the terms will be by addition. And students, when I say addition, you know that I mean subtraction also, because this is the level that you're operating on. You're at the level now where you need to understand that addition and the same thing that you call subtraction, all of those are still addition, because you know that numbers are directional. And you know that when you subtract something, you are only adding in the negative direction. You know that much. So the entire thing is addition. Also, notice that when you are doing matrices, when we get there, and some students who are aware of it, notice that we never divide matrices. Or so we think that we don't divide matrices, or we don't think that we have a matrix divided by another. Right? Because with matrices, all that we do is multiply, multiply, multiply. And if we intend to divide, we multiply by the multiplicative inverse, or the reciprocal. So for the matrices, we accomplish division by multiplying by the inverse. And you will learn a lot more about inverses as we go along or go through this CXC program. So let us attempt to take on addition. Addition. In order to add algebraic terms, we have to understand that only like terms can be combined. So only like terms can be combined. How do we identify like terms? So that's why we have to be able to identify like terms, because like terms are combined and unique terms are just included as they are. So the first thing that we have to do is we have to establish what we mean by like terms. What are like terms? That's nice. All right. So let's continue. Now, algebraic like terms, that's what we're looking at first. Like terms. Before we can add algebraic expressions, we need to be able to identify like terms. Why? Because like terms are combined and unique terms are just included as they are. So let's go. Let's say we have 7 a to the power of 5 b cubed and negative 37 b to the power of 3 a to the power of 5. Would those two be like terms? Would you say that they are like terms? I'm looking for an answer to come up right away. Would you say that they are like terms? Yes, they are like terms. Why? Because they have the same letters and the same symbols raised to the same power. So if you look here, you see that a is raised to the power of 5 there, and a is raised to the power of 5 there. B is raised to the power of 3 here, and b is raised to the power of 3 there. So those two are like terms. Yes, they are like terms. And what are their coefficients? So we're going to say yes, they are like terms, and let us write down their coefficients. What is the coefficient of this term? What is the coefficient of that term? So the next thing I'll do is look for the coefficients. Do I see any? 7 and negative 37. Excellent. Don't take that answer slightly, you know. Do not take that answer lightly. 7 and negative 37. So the coefficients are 7 and negative 37. All right. So what about these? 51 x squared y to the power of 3 to the power of 5. And 18 x squared y cubed to the power of 4. Are those like terms? Would you say that those are like terms? One person said yes. Anybody for a no? Yes. What? All right, so here it comes in now. Why is it that these two do not represent like terms? Because although we have the x raised to the same power, we have the y's raised to the same power, the z's are not raised to the same power. Because this one is raised to the power of 5 and this one is raised to the power of 4. So they are not like terms. May I have those coefficients? No? May I have those coefficients? (51) and 18. Excellent. So that is what our first exercise will be all about. Look at the terms, say whether they are like terms or not, and write down the coefficients. I'm going to copy from you 51 and 18. 51 and 18. So that is what you're going to do, students. Let's go. Those students who have your instructional manuals, they are right there. And then the rest of us will have to wait. Somebody borrowed my instructional manual the other day. All right, so let's go. A. Three x squared y to the power of 6. 3x squared y to the power of 6. And negative 7x squared. So is y squared x to the power of 6. Now students, by the time I'm finished with them on the board, you should be finished with them also. I'm going to B 16a squared b to the power of 4 and 19a squared b to the power of 3. C negative p to the power of 4 q to the power of 7 and negative 5 q to the power of 7 p to the power of 4. D negative 30 x to the power of 5 y and 4 x to the power of 4 y x. E 18 what? T to the power of 10 k to the power of 5 and negative t to the power of 5, is it? K to the power of 10. F, I hope we don't get any more apart F. 5 r to the power of 4 and 4 r to the power of 5. So, here we go. Student, if the exercise is in the manual, it means that what I write on the board is the same thing in the manual. So all of you come like you're afraid of the book. Look inside of the book and you see the exercise. Where in the book are you going to look? We just finished indices. So just go to the next page. Students, some students don't have the exercise in their books. I'm writing it on the board. And then for the one who have the exercise in the book, I have to tell her where in the book it is. Come on, do better than that, man. My mind tell me say you don't have the book, you know. Make you tell me that. Because if you have the book, you just follow one page. This page have indices. We finish indices. Then we move to the next page. If you move to the next page and you don't see it, maybe you want to see the indices homework there on that page because it's going to end on that page. Then you go to the next page. If you don't see it on that page, which of course you should see it on that page, but if you don't see it on that page, it must be on the next page. If you just follow it in order because maybe there's an introductory page there. And this exercise is not on it, but I'm sure that the exercise is on it. Just look inside of the book and look. Just after when I finish one thing, just look to the next thing. All right, so take a look at those and let me in a few seconds know what are the like terms and their coefficients. Are those like terms? Are those like terms? Of course, every day when you join this live, you're going to see something, not you particularly, but somebody in the live is going to see something that they are doing in class because it's the same thing, it is pertinent to the CXC syllabus and I'm following it to a T. So, yeah, you're always going to see, not you particularly, but students are always going to see something that they are learning in class. Some say they are like terms, some say they are not like terms. All right, let's say we don't know. What power is x raised to? X is raised to the power of what here? What power is x raised to here? X is raised to the power of 2 here and to the power of 6 there. Those are not like terms. For the two of them to be like terms, they must have the same letters and symbols raised to the same power. So the powers of the x's must be the same and the powers of the y's must be the same. So the powers of the x's are different as you can see and the powers of the y's are different as you can see. So no. What are the coefficients? No. What are the coefficients? I'm looking for the coefficients there. 3 and negative 7 is correct. So the coefficient there is 3 and the coefficient there is negative 7. No problem. The next one, are these like terms? I don't see any answer yet. Are they like terms? No, they are not like terms. Let's see. The A's are raised to the same power, but the B's are not raised to the same power. They are not like terms. What are the coefficients? So I'm looking for the coefficients now. What are the coefficients there? Lovely. I see 16 and 19 and I see 16 and 19. 16, 19. Those are the coefficients. Let's see if anybody is going to make a meal of this one. All right. Are these like terms? So we're looking at C. Are they like terms? Yes, one says yes and one says no. Another say yes and another say no. Ding dong button with the yeses and no's. More yeses than no's. All right, so let's go, students. How do we know if these are like terms? The P's are raised to the same power, as you can see. So the P's are raised to the same power. And the Q's are raised to the same power. So P to the power of 4, P to the power of 4, Q to the power of 7, Q to the power of 7. They are like terms. Yes, the order does not matter when you are determining if terms. When you are determining if terms are like terms. Sorry, the order does not matter. Yes, they are like terms. What are the coefficients? Let's see if anybody's going to make a meal of this one. What are the coefficients? I'm running away because I don't want to see the answers. But I have to look still. Five. Negative 1 and negative 5. When there is no accompanying number, students, we discussed that early, the coefficient is 1. The default coefficient is 1. However, this negative sign there means that that coefficient is negative 1. And the other one, you can see, if you can see negative signs, negative 5. That is why I notice with some students, they behave as if they cannot see negative signs. So let us look at D. Do these two represent like term? Do I get any yes? All right. It's not. All right, so let's not rush it. This one now. Do these represent like terms? Yeah, have you ever heard a yes? No. 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 Oh, yes, here's a yes again. Another yes. What students are trying to do each other with yeses and no's for this one. Yes, and some say no. Students, I'm going to describe something for you. And that one that I'm describing for you is the greatest mathematical puzzle ever created in humanity. Listen to me carefully. I'm going to ask you a question. Have you ever seen a puzzle in which you are required to look at two photographs and find all of the differences between them? Have you ever done that? Have you ever solved or attempted to do a puzzle with two pictures? Yes, you have two pictures and you are required to find all of the differences between them. All right. You see that puzzle, students? That puzzle is the greatest puzzle ever made. I'm going to ask you, students, why is it that that puzzle is the greatest puzzle ever made? I want you to answer that. Why is it that that puzzle is the greatest puzzle ever made? The puzzle with the two photographs, and you are required to find all of the differences between them. Tell me why that is the greatest puzzle ever created. I'm going to give you a little second to figure that one out. And it's because it improves your awareness. That is vague. That one is vague. I think that if you want to give a quite acceptable answer, there's one word that you have to use. And that one, no matter what you say about it after that, as long as you use that word, that single word, then you're on top of your game. Because basically it is you too. Yes. Critical thinking. I see a lot of good answers, but I know what you mean, but you have to say what you mean. When you go to some place and you say something, you have to express it out in such a way that the person has no doubt as to what you mean. Yes. That's an excellent one. That's an excellent one. That's excellent. I love that one. It makes you more observant. But there is something extra to that I'm looking at. That's excellent, you know. That's surely excellent. All right? I'm not seeing any more answer going up. Students, it is because you have to pay attention to detail. Yes. You have to pay attention to detail. If you don't spot it, then you are in serious trouble. It teaches you to pay attention to detail, and that is the greatest thing that you can ever do in mathematics. Go back to this one now. The y's. What is the power of y here? And what is the power of y here? They are the same. So we are on, but not yet, and not quite. I see that coming up. Thank you very much. That's the power of 1. Lovely. What is the power of x here? And what is the power of x over here? So, y is in our favor already because y is raised to the power of 1 on both occasions. So we have to go now to the x's. What is the power of x here? And what is the power of x here? I see 5 and 1. I see 5 and 1. Come on, students, you are not looking. The power of x here is 5. What's the power of x on this side, this one? What is the power of x in this term? You are saying 4, you're saying 5 and 4 and 1, as if you are talking about 3 different terms. So you, Mr. I don't know if it's male or female, that say 5, 4 and 1. It means that you identify what you should identify to answer the question. Because you see all of the indices. You have seen all of the indices, while some of the students only see 2 of them. They only see 2 indices. Now, you see 1. Look in this term here. We see 4, x to the power of 4, y, and then x again. There is no one inside here who can conclude that right here, the power of x is 5. No one can see? What is this in mathematics? X, then x to the power of 4, and then x again. What is that equal to? Of course, everything inside here are being multiplied. Right, so these are being multiplied. X to the power of 4 multiplied by y multiplied by x. So if all of those are being multiplied, what are you going to do with the x's? The x's are the same base, so you're going to add the indices. So this is equal to x to the power of 4 plus 1, which is equal to x to the power of 5, same way. There it is. See that? Sir, the x has a power of 1, so add them and it becomes 5. So it's a like term. Exactly. Exactly. We need to put the x's here together. When we put them together, we are going to get x to the power of 5, and that will cause it to be a pair of like terms because we have already concluded on the y's. So yes, those are like terms. And let me have the coefficients, please. I'm not going to take this out yet. Let me have the coefficients, please. Negative 30 and 4. I was expecting that in. No? Well, I'm going to put that in nonetheless. Negative 30 and 4. Those are the coefficients. Let's finish up, students. Let's finish up. All right, so let us take a look at E. Are they like terms? Come on, let me see the answers for that one. And 4, yes. Negative 30 and 4. What about these? Let me get out of the way. Are these like terms? No, I see some no going up there. Yeah. No, and another one. No, they are not like terms. So let us see. Maybe you can just look at it very quickly. See? T is to the power of 10 here, and T is to the power of 5 there. They are not like terms. What are the coefficients, please? Whether that good no. Maybe you're saying that big no for the next one too. So of course, let me write the coefficients down. 18 and negative 1. Let's go to the final one. 18 and negative 1, yes. Surely 18 and negative 1. Are these like terms? 5r to the power of 4 and 4r to the power of 5. Are they like terms? No. No, they are not like terms. And what are the coefficients? Excellent. 5 and 4. And we are finished with that exercise. Good. Now, students, we're going to go over to another exercise. Yeah, there's going to be some nice jumping jacks going on. Now, students, somebody came in early today, well, by TikTok standards, because they did not let me in until about half an hour later than I should have started. All right, so someone said that I should do some fractions with maybe working with algebraic fractions. Let me tell you what CXC does, students. If you're working with algebraic fractions, they give you, these are some of the things that they will give you in algebraic fractions. They'll give you an equation consisting of algebraic fractions. So that's one. They'll give you indices problems. Because if you look at some of the indices problems that we're going to solve, or maybe I have on the video, you will see that they are given to you, the problems, and also in multiple choice, they are given to you in fractions. So those are algebraic fractions also. And sometimes they give you fractions for you to simplify. Meaning that maybe they give you 2 fractions to add and you're going to write the answer in its simplest form, or they give you 2 fractions to multiply and you're going to write the answer in its simplest form. So as it pertains to algebra, there are thousands of ways that they can set the problem. Now, do not imagine that somebody is going to put something inside there and I see, and because I am not teaching it today, that I don't give it consideration. I give everything and everyone consideration. So don't believe that because I probably brush it aside initially that I will not. Yes, I'm going to do a lot of stuff like that. We have 2 large tutorial books, and I'm sure that whatever problem you are talking about and whatever aspect of the course, that those problems are inside of those books, and we are going to be solving a lot of those problems. So there's nothing missing at the moment. I still do not understand D. Students, it's not that you don't understand. So let me tell you the problem that you have. You have a preconceived notion. And when you find out that you're wrong, you refuse to let it go. Which is a horrible thing. It's disastrous. Now that I'm done telling you that, I'm going to put it on the board again, and I'm going to explain it again. And if you do not, tell me that you do not understand it again. Let's go. Why would someone say that these do not represent like terms? Is it because you don't see an occurrence of x there, and you don't see another occurrence of x there? You don't see those? Is it because you don't see them? What is the power of x that you see here? You see x to the power of 5 there. the powers of x you see here? X to the power of 4, x to the power of 1. You can say no see it. You can say don't see it, you know. Now the discrepancy could never be with the y's because it's just y and y. So the discrepancy must be with the x's. So we see x to the power 5 here. We see x to the power 4 here. And in order that these will not be like terms, we have to just pretend that this x to the power of 1 is not there. Or it has no significance. Or it is not contributing anything to the term. It's not a part of the term. It does not exist. Does its presence have any effect? The only reason that you would fail to see that these are like terms is if you do not see this. Is if you do not see this as x to the power 5. If you don't see that as x to the power 5, then I will understand. Is there anyone who did not see x to the power of 4, then x to the power of 1 together in the same term, being x to the power of 5? Is there anyone who does not see this as x to the power of 5? Tell me, because I'm going to show you that if you still say you don't see it as x to the power 5, I'm going to show you that it's x to the power 5. All right. Since no one will answer, I'm going to show you that it's x to the power 5 then. What does x to the power 5 mean? It means that we have x times x times x times x 5 times. 1, 2, 3, 4, 5. That's what it means. So that is equal to x to the power of 5. What about this? The x to the power of 4 is what? X. 1, 2, 3, 4 of them. That is what x to the power of 4 is. And then the x, whether you want to put it with the power of 1 or you just want to put it x, you need to put the x there too. And then when you count them, 1, 2, 3, 4, 5, you'd still get back x to the power of 5. That's excellent. Just add the indices. But if you do not add the indices and you go right back to put down the x to the power of 4 occurrences of x, and then one more occurrence of x right there, and when you count them, you get 1, 2, 3, 4, 5. It's going to be x to the power of 5. Come on, students. You can't say no to say x to the power of 5 now. You can't, no matter how you're dangerous, you're wicked to yourself. You can't say no to it. Right. So we are sure that it's x to the power of 5 and they are like terms. No, students, because the instructional manuals, some of you have the instructional manuals, some don't. But those who have the instructional manuals, you are behaving as if it has coach on it. So you know what I'm going to do? I'm going to read it so that you can't say you don't see it. So if you say you don't see that, I'm going to let you know that it is there. So we have identified like terms. When we add algebraic expressions, we combine like terms and just include unique terms as they are. So when you are going to add your algebraic expressions, you identify the like terms and you combine the like terms. Right? You put all of those like terms together and make one term out of them. This is how you do it. In combining like terms, the coefficients are added. The indices are not affected in any way. So let's say it again. In combining like terms, the coefficients are added. So for like terms, you're going to add the coefficients. For the like terms, you're going to add the coefficients. The indices, when you're adding like terms, the indices are not affected in any way. Right? Yes. So the indices are not going to be affected when you are combining like terms. Only the coefficients will be combined. Let me give you an example. I'm going to give you simple examples because all of the examples of the term are the same. The terms are the same. Now students, let me give you a little scenario before I go on. When students see that I'm finished with the directed numbers, oh, glory to God, Mr. James, we get finished with these now. No, you don't start to apply directed numbers yet. You're just looking at the fundamentals and how they work with their one another. But now that you're going to apply them to this, it does matter. And when you start to do some other stuff, as I said, the algebra book with what? With 7 topics. I think it's 8. So the algebra book has 8 topics. Functions part 1 has 7, that's 15. Function has 2 has 5, so that's 20. 24 topics will be riddled with directed numbers. You cannot avoid it. So let's go. This one is going to be much like a directed numbers problem too. But let me put some on the board. Let's say you're going to add. I'm going to put 3. So let's say you're going to do this. 5a squared b cubed. I'm going to do something about these markers. Alright. Let's say we have 5a squared b cubed plus 7a squared b cubed. What will that be? What did we say? In combining like terms, the coefficients are added. The indices are not affected in any way. So let's go straight ahead. Add the coefficients. You know coefficients, because we were doing that quite a bit with old coefficients just now. So add the coefficients. Let's go. When you add the coefficients, what do you get? I don't see anybody yet. equal to 12. Then we have going to have what? A to the power of 2, b to the power of 3. Why? The coefficients are not affected when we add. What is that equal to? We are going to add the coefficients again. And of course, they are different signs. They are of different signs, or they are of unlike signs. Because they are of unlike signs, what do? Subtract, and the answer will take the same sign as the larger. So we subtract, and we get a 2, because the sign of the larger one is positive. The answer is going to be positive 2, and it's going to be 2pq. Very nice. xy plus 13 xy. What is that one? xy plus 13 xy. xy 14 xy. So many? Of course, because the coefficient here is 1. So 1 plus 13 will give us 14, and it's 14xy. Very nice. So what I'm going to do now, I'm going to put, I'm going to get crazy with these markers, you know. Oh, one more marker is in this one. More one doesn't matter. Alright, students? Nice. No. That one not going to work. So, students, let's go. All of these are very nice problems. They are delicious. Please, students, may I go until 8:30 because of the late start? If we will last that long. So this one is, we have 13 problems there. So let's go. Number 1, 7x plus 11x. Number 2, 7x minus 5x. Number 3, 3x minus 6x. Number 4, negative 2x minus 4x. Number 5, negative 8 x plus 3x. Number 6, negative 2x plus 7x. Number 7, a minus 6a minus 7a. Number 8, m plus 13m minus 6m. 6b squared minus 4b squared plus 3b squared. Nice. Number 11. Nice. Anybody finish yet? All right. When I move students, I'm going to take out the first 6. So that's what I'm going to do when I'm ready to go to the board. I'm going to take out the okay. That's nice. Students, don't put 17. All right. All right, I will accept the 17. The reason for accepting the 17, some of the algebraic expressions are too sophisticated for just a regular typing. But you know that the answer is not 18, you know. The answer is not 18. Because I say the answer is not 18, let me see if anybody will tell me what the answer is actually. Of course the 17 was a mistake. But the 18 is also a mistake. Yeah. All right. So remember now I'm going to, yes, 18x. Of course, the reason why I'm saying I'm not going to be so harsh on the x's and so on is because, like, maybe when you're going to be doing something sophisticated, you might not be able to write the algebraic term. For some students might not be able to type it. I see people putting the indices there quite nicely. All right, students, look here. Don't do that. Remember how loudly I read this? I'm going to read it one time more. Nothing else after that, just one time. Let me go back to it. I just say no big it to myself. Let's go. When we add algebraic expressions, we combine like terms and just include unique terms as they are. In combining like terms, the coefficients are added. The coefficients are added. The indices are not affected in any way. Remember I read that? The indices are not affected in any way. The indices are not affected by addition, students. They are only affected by multiplication and division. So this one is going to be what? 18x. Next one. Come on, everybody must get that one right. The one following that. Okay. Apology accepted. Someone says 2x. Yes, it's 2x. If you don't know directed numbers, you're going to make a meal of the exercise. I'm taking the first 6. 3x. 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 Negative 3x. Do not forget that the sign must take what? Must be the same sign as the larger one. And here we have a negative 6, which is the larger one. So the answer must be negative. Let me see what we do with that one now. What do we do with this one? Whenever we, I'm not going to, yes, whenever we add numbers that have the same sign, we add the values. The signs are the same. We add the values. And the answer will take the same sign as the numbers that we have added. So the numbers that we have added are negative. Anything more for number 5? Number 5. Number 5 is 5. Well, somebody put negative 5 is correct. I see a negative 5 and that's correct. Yes. So, for this one, whenever we add numbers with different signs, we subtract the smaller from the larger. So when we subtract, we get a 5. And the answer will take the same sign as the larger one. So it is when we are finding the difference, that is when the numbers have different signs, that we cause it to take the same sign as the larger. Those are of different signs again. What do we say? I'm sure that I saw the answer there already. Right, so now take a deep breath and we're going to do numbers 7, 8, 9, and 10. Yes, 4. 7, 8, 9, and 10. So I'm going to take a little break. I'm not going to ask for the answers as yet. And I'm not going to look at them either. I know that some of the students would have worked them out a long time ago. And they are waiting on me. So let's go. Negative 5a. Alright. Now students, the reason for this long delay is because I want to work it out in more than one different ways. So let's go. Some students may do it like this. 8a minus 6a. So 8a minus 6a will be 2a. So 2a minus 7a is equal to 2a minus 7a is going to be a negative 5a. And some students might want to work it out like this. 8 minus 13a, and that is going to give you negative 5a. So some students might want to may combine the first two first to give 2a, and then they say 2a minus 7a is given a negative 5a. Or they will want to say, put the 8 is 8a. Or they put back the 8a and combine the two negative terms. So when they put the a and combine the two negative terms, they will get a negative 13a, and they would work it out like that. Nice. This one, what is the answer that you have? M is correct. And I'm going to work it out in the two ways that students might want to work it out that way. So let's go. The student might want to say 5 plus 13. So let's say that is 18m minus 6m is equal to 12m. Or, what will they do? Well, it's the same thing. Or they might just want to say 5m plus, because this one is 13 minus 6 is 7. So they might want to put the 5m and then put these two together, and they say 5m plus 7m is equal to 12m. So they would probably want to do it differently. So what do we say about number 9? Alright, since everyone is waiting on me, let's go. Since you're waiting for me to do it, I know you're not waiting, maybe you're putting in the indices and they have some difficulty writing the index. See what I mean? Some says what? I see 1, I see 5b to the power of 2, I see. Let's go. And I'm going to work it out two ways. One might want to say that we have 6 minus 4, so that is going to be 2b squared plus 3b squared, and that is equal to 5b squared. Another person might want to put the 6b squared with the 3b squared, so they're going to put the positive together, minus 4b squared. So they put the positives together and they'll still get the correct answer. I'm not limiting you to, oh, maybe somebody did number 10 already. That's why they're telling me that it's 1 for the coefficient. Students, if the coefficient is 1, you do not have to write that coefficient. Let's go. One AB and some says AB and some says AB. All right, so that's excellent. So what do we have? One might say it is 6ab minus 3ab, and that will give you 3ab, and then you're going to minus the 2ab, minus 2ab, and that is equal to ab. Or, you might want to say what? Put the 6ab by itself. And then you put the negative 3ab with the negative 2ab, and you get negative 5ab. So 6ab minus 5ab is 1ab, which is equal to ab. Which one am I going to work out? Number 13. But I'm not going to work out number 11. Anybody has the answer for number 11? Do not forget that what? 2 takes longer than 5. Yeah. Alright, so now students, pay attention. It is noteworthy. Number 12 is negative 3x. And some put in number 11 as 14xy. Now, pay attention to this, students. You see, when I see a sophisticated problem like this, there's a rule that I use. Solve the easy problems, yes? Solve the easy problems and allow the difficult one to work themselves out. So you're going to solve the simple. We have solved all of the simple ones. This seems a little bit more, cumbersome. Look at this now, students. Well, somebody say it is what? 14xy. Now, students, if we have a 14xy here, and the answer is 14xy, it means that these would have cancelled each other. Because what? We have a what? 5xy with a 2xy. So when we put the 5xy with the 2xy, we get 7xy. Then after 7xy minus 7xy. And all that is left is the 14xy. Do you see that? Right. Because, let me say that again, we have a 5xy here and a 2xy, that will make 7xy. Then the 7xy will minus, so from that we minus 7xy. So the 7xy minus 7xy, those two have a cancelling effect on each other. And all that is left is the 14xy. I think that if you look here again, you'll notice the same thing. You have a 7x here, so the 7x is there. And then what do you have? The negative 5x and the negative 2x. So the negative 5x with the negative 2x will be negative 7x. And then we have a negative 7x here, and we have a positive 7x there. They have a cancelling effect on each other, and the answer is what? Negative 3x. Negative equals negative 3x. Now, how would I do this one? This is how I would do it. Although we could just look at it and tell the answer, but this is still the logic behind it. So let us put that down. Negative 4x minus 3x minus x, no, it's squared. All of these are x squared. Plus 2x squared. So we have a negative 4x squared, a negative 3x squared, a negative x squared, and a plus 2x squared. Of course, when we put all of these together, what do we get? When we put all of those together, what do we get? A negative 4 with a negative 3 with a negative 1. 4 plus 3, that's 7, plus 1, that's 8. So that's a negative 8x squared plus 2x squared. And from your directed numbers, that will be equal to negative 6x squared. And that's all there is to it for that one. That's nice. Thank you very much for all of those wonderful gifts. I say a big hearty thank you. So we see Mr. Bogatti, Boogie Bogatti. That's nice. That's a nice name. That's a lovely Italian name right there. So let us continue, students. What will I do? As I promised, well, I'm going to ask you because we just spent half an hour, but we don't have to spend the entire half an hour because we just have one exercise left, do we? I will have to look in the new manual. All right, but I'm going to be, I know that at least the first one is there. So I'm going to look if we have any classwork for that one. I'm using the old manual, students. That's the one I'm using. Homework. I like that. You better do it by Thursday so that we can have some fun. So that. Okay. All right, so let us do the last addition and subtraction part. Students, I hope you recognize that I'm progressing in a strategic manner. You're going to add algebraic expressions. You have to be able to add like terms. Before you can add like terms, you have to know what like terms are. Now that you know what like terms are, you combine them. So that's what you have done here. You know what you're going to do in the next exercise? You are going to identify the like terms and combine them. So the first exercise, you identify like terms. The second exercise, you combine them. The third exercise, you identify and combine them. That makes life jolly jolly. So I'm going to have those on the board in a second or a third. Yes, you're going to have that on the board in a second or a third. I think I'm going to need more whip. Let's go. So in this exercise, there are two problems. You're going to identify the like terms and then combine them. A. Three x squared y cubed minus 20xy squared minus 20xy squared plus 21xy squared plus 21xy squared minus 2x squared y cubed minus 2x squared y cubed. And what else? 17x squared y squared. Plus 17x squared y squared. That's very nice, man. Alright, so you don't know what I'm saying, very nice though. B, let's see what to make of B. A cubed B plus 6a squared b squared minus 10ab cubed minus 10ab cubed plus 16a cubed b plus 16a cubed b minus 10ab cubed. You should at least finish the first one already. Students, you see the algebra book? You have to know it like your morning watch. Yes, the algebra book, you have to know it like the morning watch. Because if you don't know these, it's going to come back and haunt you when you need to apply them to something else. You're going to surely need to apply these to something else. Students, you see right after this? Right after algebraic expression is factorization. And believe me, you better get on top of it right away. Make sure that you do the homework part. I'm going to tell you which part to do for the homework part. Yes, I'm going to tell you which part to do. Because I don't need to tell you, because you would know that all that we did for the algebraic expression was addition, subtraction part. So when you go to the homework, you do the addition, subtraction part. I really didn't have to tell you that. because you did no multiplication and division in this class, so you wouldn't do the multiplication and division part. All right, so let's go, students. Let's go. Let's go. You know that I don't want you to do it in one. I want you to do it in two. You're going to align the like terms together. So put the like terms closer to each other. Rearrange the expression. So your first step should be a rearrangement of this expression, putting the like terms beside each other. Do not forget the unique term. It has to be included just as it is. And then you combine the like terms in the next step and finish. Let's go. So let's go now. What I will do, I see 3a squared y cubed, and it is the like term with negative 2a squared y cubed. So those two are like terms. This one with this one. So let's write them. 3x squared y cubed minus 2x squared y cubed. What else do I notice? Any more? Well, those two are close to each other already. 20xy squared, negative 20xy squared plus 21xy squared. Negative 20xy squared plus 21xy squared plus 17x squared y squared. Beautiful. I'm sure that you can follow, right? You should be able to follow, and I'm sure that you're following. Reason being, you did your identification of, you did that exercise, you did that one. Identifying like terms. So you can identify like terms, we did that exercise. And of course, after that one, we did the combining like terms, and that's what we're going to do now. So the coefficient here is a 3, then a negative 2. So 3 minus 2 is 1. So it is 1 for the coefficient of x squared y cubed. We do not have to put that one. X squared y cubed. That's all it is. Do not have to put that one. Then we go to these two. I'm going to put the spiral on this one too. Yeah. So I go to this one. We have what? A negative 20xy squared plus 21xy squared. So we have a negative 20 plus 21. Your directed numbers again. Negative 20 plus 21. So that's still a positive because it's going to take the same sign as the larger one. The larger one is positive, so it's going to be a positive xy squared. And then the unique term will go back just as it is. No problem. So it is the same thing. We're just combining the exercises that we have done so far. So if you did the first exercise and you did justice for yourself, and you did justice for yourself on the second exercise, well, on the third exercise, you're going to do a lot justice to yourself also. Now, students, I cannot emphasize, I cannot overemphasize, I cannot stress, I don't know what to say. Any one of these topics that you fall short on, you are going to find the progress extremely difficult, if not impossible. You must know directed numbers, you must know indices, and you must know basic algebraic expression. You know that another thing you must know? Because you and I are going to have a little fist it out if you do not know your multiplication table. So if you do not know your multiplication table, make sure that you study them till you know them like the back of your hand. Because if you do not know your multiplication table, you are going to have difficulties. I saw a teacher on TikTok saying that my students want to do well at this subject and they don't know their multiplication tables. She said, how are you going to do well at this subject if you don't know your multiplication table? She's outrageous. She's angry. She's at her wit's end. Saying that if my students do not know their multiplication table and they want me to teach them mathematics, I cannot teach them because they do not know their multiplication tables. And she was really very angry. So, the next topic after this one, we're not going to move to it immediately, but I'm letting you know, is factorization. Where you have to know directed numbers, you have to be able to divide, you have to be able to multiply, you have to be able to add algebraic expression. Everything, as you're going to make a meal of it. Exactly. All right, so let us do this one. What do we say about that one? Put the like terms together. We have a cubed b. Do we have another one? Right here. Do we have another a squared b squared? No, we do not have another a squared b squared. Do we have another ab cubed? That's one. Yes, we have another one right here. Beautiful. So, put the like terms together. A cubed b plus 16 a cubed b. Then put the others together. Minus 10 AB cubed minus 10AB cubed. The unique term plus 6A squared B squared. And I'm ready for the answer, but I'm not going to write it on the board. I'm going to give you a shot at it. All right. Let me see if anybody has it inside here. Oh no. All of my excellent students who used to supply the answers. They are not doing that now. And I'm so disappointed. So let's go. Students, we have what? A cubed B plus 16A cubed B. What's that? Well, at least you should be able to give me the coefficient. Give me the coefficient if you cannot give me the entire thing. Let's go. Excellent. So 17. So the coefficient here is 1 and the coefficient here is 16. So when we put them together, we get what? 17, and the indices are not affected. Do not forget that the indices are not affected during addition or subtraction. Now you're going to put these together, the AB cubed, AB cubed. Put these together now and tell me what you get. Negative 20AB cubed. Excellent. So of course, these have the same sign. So when we add them, we are going to add the values. So add the values. And the answer will take the same sign as the numbers that we have added. And AB cubed plus 6A squared B squared. Lovely. Now students, for the homework in algebraic expressions, we have the addition subtraction part. We can just say addition part. We have the addition part, and what else do we have? We have the multiplication division part. Student, make sure that by Thursday you give it a shot. Make sure that by Thursday you give the addition subtraction part a try. You did that part of the homework. Because I would want to do that in class first thing, and then we go to the multiplication division. And with time remaining, we'll begin your favorite, factorization. Right? It will be factorization after that. You cannot factorize, students, if you do not know directed numbers, if you do not know indices, if you do not know how to manipulate algebraic expressions. So for those students who have just sitting down, waiting for those topics to finish in order to throw them into the abyss. Yes, those of you who would have been waiting to throw those topics into the abyss, they're not going in there. They're coming out to haunt you if you don't ensure to learn them, to internalize them, be able to apply them to all different circumstances. Now, the books that we are using, let me go for a set of books. Students, this office was converted to a book factory over the weekend. I hope that there is no surprise. There could not be any surprise because all of the books that you see in Richard James Mathematics Resources, they were made in this office. The only thing that was not done in this office is the perfect binding. Yes, the perfect binding alone was not done in this office. So students, your algebra book. The reason why I'm laughing is because, let me see if I can find my algebra book. Yes. Students, your algebra book. Nice and nicely bound. Right. So that's your algebra book. And it's for $2,000. My algebra book, students, it's more of a fun than anything else. My algebra book with the spiral bound. Yes. That one is out of commission right now. So it is the new one. And for some students who are just getting in and you don't know anything about Richard James Mathematics Resources, we have 7 instructional manuals. So for everything that you are going to learn in the CXC syllabus, we have, I'm going to write another manual. Yes, I'm going to write another manual about some things that are in the CXC syllabus. But because they don't come on exam often, there is no manual for them. So I'm going to write a manual for that one. And that is going to be the most exciting manual that you will see in your entire life. So we have the algebra. We have trigonometry. They are not in order. Yes, trigonometry. This is the only hybrid manual that we have at the moment. I think that I'm going to include another one. This is the only hybrid that we have. Computations Part 2 and Geometry. Computations Part 2 has set theory and statistics. Then we have Geometry. Do we? Yes. So we have measurements. We have construction. We have circle theorem. And there's one that I'm missing. So we have measurements, construction, circle theorem, that's 3, And another one, oh, just something discussed in the circle. So we try to show you the parts of a circle, so it's a small topic. But I think that I cause it to be have some serious significance in this book. So this is the only hybrid book at the moment. This one is not a hybrid book yet. I'm going to make it into a hybrid book. This one is Computations Part 1. Students, your mathematics continues from over by your primary school to CXC. So inside here, you have indices. Sorry, not indices. Let's go back. You have ratios, percentages, simple and compound interest, foreign exchange, decimal places, significant figure, and standard form. And of course, for reasons that I will not discuss at this moment, we have direct and inverse variation in this book also. Go anywhere in the world and carry any book that you see comparable to this one. You will never see any book that is of a similar nature that is comparable to this one. This is Functions Part 2. Yes, Functions Part 2. And I'm going to extend Functions Part 1, but I don't know when I'm going to do it yet. I'm going to extend Function Part 1 to contain solution of linear inequalities. So this is Functions Part 2. This book contains stuff like maximum and minimum of a quadratic expression by using completing the square and by also making use of the axis of symmetry. It has sketching parabolas, and it also has the solution of quadratic inequalities. Then the other two topics that finish this book will be what? Linear programming and velocity and distance time graph. I'm going to extend these in a while, you know. Functions Part 1. Functions Part 1 contains functions, your basic functions all around. So it has functions, quadratic graph, equation of a straight line graph, gradient of a curve, completing the square, solution of quadratic equation by completing the square. So many. These books, you'll find them to be extremely useful. Algebra, I mentioned that already. And this one, vectors, matrices, and transformation. This one is bad, may I tell you. Dangerous book this. If you look inside here and see the ruler inside it, if you see the ruler, right, you see the ruler inside here? Yes, I created the ruler and the set square. Yes, I drew those with my hand. So you know that it's wicked. Yeah. So this book is very sophisticated, especially as it pertains to transformation. All right. And of course, there's something that I need to mention, you know. I hope I don't forget it. Your two tutorials. Tutorial 1 and Tutorial 2. These books are your companion. You keep them close to you for the entire year. You cannot solve all of the problems that you have in these books. You solve, and solve. When you think that you almost reach halfway in the book, not the full way. When you think that you reach halfway in the book, examination time is upon you. And when examination time is upon you, what happens? When examination time is upon you, you go to paper 1 practice, no, wrong. Paper 1 practice and paper 2 solutions. So we have everything in these resources. Everything we have in these resources. So, if you're doing your examination, if you don't purchase mathematics resources, it's because you do not want to pass. Because believe me, there are so many things inside there prepared to your hand. Yes. Yes, there are so many things inside here. Tell me something that you need to do in preparation for CXE. that you think is not in those books. Construction, all right, we said that already today. So everything is there. So of course they'll come at a cost. But if you realize what I'm trying to do, I'm trying to write as much of it as I can on the board, so that students can still follow if they don't have the instructional manuals. Because there's no need that I'm saying I'm not writing it on the board. If they want to see the exercises, they will just buy the manual. Because the students who don't care, they're not going to buy the manuals anyway. And the students who care, they're going to buy the manuals anyway. And it's not the only manuals. It's a lot more stuff. Here's when they say everything is there. Yes. Come on now, students. You go to a mathematics class. The teacher gives you 7 instructional manuals, 2 sets of tutorials, a paper 1 and a paper 2. In total, 14 pieces. You think you'll find something in CXC that not inside of the books? Oh, sorry about that. I'm infringing on the students' time, and they should have been out from 7:30. So I'm sorry, from 8:30. So they are 7 minutes too late. So in a few minutes, I will have to say goodbye. Now, students, do not forget tomorrow class. Let me say that again. Do not forget that tomorrow's class is functions. We are working with functions. And it is, you can come in, you should join. But you do not have to join. Because it's mainly for the students who are doing the examinations in January. But if you join, you're still going to learn something. And I'm going to teach this again in January, and maybe not on a Tuesday. No, you're not absent. Students, you cannot be absent, you know. You cannot be absent. Why? You cannot be absent because, I'm going to give you another thing to do. You cannot be absent because you have the instructional manuals, you have audio visuals, you can go back through the lesson. I think that the lesson is always going to be saved on YouTube. Somebody is suggesting that I set up a Google Classroom. That's a wonderful idea. I decided to do that during the COVID lockdown. But I have 2 IT people. One of them is hardware and one is software. And the software one died. So it kind of pushed me off a little bit. All of these things, I am man have to go through earth, you know. Yes, she died. And that gave me because the app should have been out before the COVID lockdown. I don't have the app. We should have a Richard J's Mathematics Resources app. You don't know how hard it is. It is easy to pick up the pieces when somebody decides to leave you and go about their business, but it's harder when somebody dead you. Harder when somebody don't make it. Alright, so students, I see some individuals sending me, what they call it, some message thing, and you have to accept, or you delete, or you deny. No, I accept all of them because I know it has to be pertaining to the mathematics resources. So you can send and ask me question. Students all, do this. I'm going to start to let you also, what I call it, go to Richard James Mathematics Resources. That's on Facebook. And subscribe to that too. Reason being is that some students, I heard someone, I cannot scroll through so many videos. Students, I don't have 1,000 videos up there yet, you know. I do not have I do not have 800 videos up there yet. And I have 5,000 videos. Is that so many I have? 5,000. You see, for the matrices, I'm not going to do matrices until I finish functions 1 and functions 2. And it's going to be done on a Tuesday. So you can expect that to be done closer to December. Or even during the holidays. And why would somebody say matrices? Matrices is a methods problem. It's a methods topic, you know. You just use the methods that they tell you and you just go through with it. But we're going to take a look at it and make something out of it when we get there. Every single topic, if it misses you, then it's just missed you. But every topic in the CXC syllabus will be discussed. Every one. But of course, you know that I cannot discuss every one of them immediately and together. I will have to do it in a logical sequence. Well, you know, that's another thing. You are new to 11th grade, and I'm sure that all of the new 11th graders are new. So you're not like a person that is different from the rest. You just need to apply yourself. They're going to go through the same thing, you know, going into 11th grade with anxieties, you know, with ifs and buts, and all of that. It all comes with going into 11th grade. Students, the person who is new to 11th grade, how old are you? The person who is new to 11th grade, how old are you? We have people used to go in 11th grade when they are 14 and leave the high school when they are 15, you know. Well, I went into 11th grade when I was 15. I went into 11th grade when I was 15. This year, students, if I'm doing classes, sir, you don't do one-on-one too. All right. Sir, you don't do physics also. When I do some classes, last year students were inside the classroom. This year, no. Then this year, no. Sir, you don't do face-to-face also. Sir, only online classes you do? Students, maybe next year, next year, you might not see me in the classroom next year. Yes, it's only online for this year. Next year, it might be no line. Okay, students all. It was a very good class. I think that you did extremely well in your manipulation of algebraic expressions. I thank you all for sharing the live. I thank you for inviting others. I thank you for participating. I even thank you for joining. Thank you for everything that you have done in contributing to the class being an excellent one. I think it's an excellent class. And I couldn't have done that without the students. So a big thank you to you all. And when you see the hands go up, you know that the class is at an end. So for now, students, if you want, you can send me a message. Tell me if there's some concern you have and I might be able to answer. So for now, it is what? Have a good evening. Have a good night's rest. Do the addition subtraction part of the algebraic expression homework, so we can discuss that when you return on Thursday. So until then, until Thursday, no, not Thursday, students. Some students will be coming on tomorrow evening, those who are doing the receipts, and some other students who are interested, because we have even 9th grade students who are interested, and I'm delighted to have you over there also. So tomorrow, do not forget that accelerated class for the receipters, and then normal programming on Thursday. So for now, it is goodbye until Thursday.